some parts arrived, and I've got this top boost circuit ready to go back in the amp. As I mentioned, I went with a Nishikon 33 microfarad filter cap for that node. And let's see, the best way to explain this. I'm trying to inject some certain qualities to the sound that the originals have that many builds don't have, that this build certainly lacked. And much is made on the internet, too much in both directions, of carbon composite resistors and metal films. And the metal film camp says that you should never ever use a carbon comp because they're noisy, blah, blah, blah. And the carbon comp camp says you should never use a metal film because they're sterile and blah, blah, blah. And they're both right. And you got to step back and look at what you're trying to achieve and what role a particular component plays in the circuit. And there are places where a carbon composite will do nothing but add noise. And there are places where it almost doesn't matter what the material is. You're not going to have any issues either way. And there are places where, particularly when there's high voltage present across the resistor, where there can be some complex distortion caused by the carbon composite. And Aiken's got a good article on this. If you want to read up on this, I've got a link in the description. Basically, in a new amp, I would rarely use all carbon composites. In a restoration of an original, if the original had carbon composites, I do, because I'm restoring. This amp straddles the line because it is a new amp and it is trying to sound like the old one, but that does not mean that we need to replace all the carbon comps with carbon films or metal films. Neither does it mean that the amp sounds exactly like an old one, only with carbon films. It does not. And a lot of what I've done, which nudges it closer to that, is lead dress and some better quality capacitors here and there. But now I'm going to be introducing a couple of carbon composites to very specific places in the circuit where in my experiments in the past, where I have had a whole bunch of resistors on switches, so I can try different wattages, different materials in circuit, all with exactly the same resistance. And so I've taken that variable out. So if I'm comparing 300K resistors, say metal film, carbon composite, I've measured, I know that they all actually are 100K, and I'm not going to be hearing any differences based on variation in the actual resistance. And I've done it blind, by which I mean I've had it set on a rotary switch, and I've had my wife flip the switch, and I listen and play. And I do that multiple times, and if I do, am I hearing a difference? Am I imagining that I hear a difference? If I consistently can pick out a certain sound as being different than the others, and I like that difference, and when I get the results, that was always position 3, that I didn't know what I was hearing, and position 3 is a certain material or a certain wattage or a combination thereof. I've also done this comparing half watts and 1 watts in amps. Sometimes there is a truth to that, and sometimes there's internet mythology, and I want to test all that. But scientifically, a carbon composite resistor does distort differently and at different frequencies than a metal film or carbon film. So they have their place, so does a class 2 ceramic disc cap, as opposed to a more modern sounding ceramic disc with a higher rating, or a really cheap one which has a terrible temperature coefficient, so it's not going to sound the same on Tuesday as it does on Wednesday, versus a silver mica. So I think this is some very judicious applications of the old class 2 ceramic, of carbon composite. And the owner used Mogami shielded cable for his shielding, and there was nothing wrong with that cable except that the center conductor is like 26 average gauge, and it just breaks if you look at it too hard. I've got this RG174, which has 22 gauge, and I trust those connections to hold up a lot better, though I am reinforcing them. And I'll add some more of this reinforcement as it goes in. This will sit in the chassis like this, and the heater wires will go beneath the board and tie into the heater supply. And the red and black are going to go underneath the board and tie into the B plus and ground. And then the shielded wires are going to go to a place in the chassis up here. So this will be run like this, and the heaters will be run like this with some space between them. And then this will be up here with a lot of space now between the heater wires and the signal wires, whereas before they were all just kind of together and running in parallel very close to each other. So these are, if someone gets turned off by seeing me put carbon composites in here, I have a holistic view of this. I'm stepping back and looking at the grand scheme. And everything I'm doing is measurable and predictable and good, best practice to the best of my knowledge and abilities and a lot of experience. So let me dive in and make some changes to the main board now, and then we will reunite this little top boost card with the rest of it. Real quick though, one thing I did, just if only for my sake, and the owner can change this if he wants, these knobs don't have any indicator line, and before they had it so that the set screw was on the opposite side of where the position was. I'm using the set screws as the indicators, so that noon, 2 o'clock, 10 o'clock, 5 o'clock, full up. That set screw lets me know where they are, so I can make sure that my o'clock positions are where I want them to be. If the owner wants it to be the other way, he is obviously capable of building things. He can take these off and put them where he wants them. But I like to know that, oh, that's the relationship at a glance. I like the visual cue. Maybe that's just me. Okay, as you can hear in that little sneak peek video I put up last night, the amp is overall sounding immensely better than it did when it came in. You can see I've got these Vishay MKT 1813 150 nanofarad caps on the output of the phase inverter. So the actual JMI value, but 630 volts rather than 400. I changed the plates, which were perfectly matched 100K carbon films, to some 10% tolerance carbon composites. And they're both hovering near 100K, but they're not precise. And that imbalance in the output can lead to interesting things harmonically. Similarly, the 47K, 1.2K, and 1 megs in the phase inverter grid leaks, cathode, and tail are also carbon composites. That's a place where there's a fairly good amount of voltage present on that cathode, and it can make the response a little more interesting, but there's such low voltage there, and the values that the voltage goes through, 47K and 1.2K, are low enough that you're not introducing a lot of noise. Similarly, in the output, phase inverter, there's not a lot of amplification in that stage, so you're not going to get a lot of self noise from these carbon composites. I did use the carbon composites, as you can see, in the top boost circuit, which does have high signal, high gain, and quite a bit of voltage. I used it for the plate, the 56K cathode, and the 100K slope resistor. But those are after the initial gain stages in the amp. So there's less gain there than there is on the first stage. On the first stage, I kept the 220K carbon films that the owner used, 1 watt carbon films, so it's still very low noise. The remaining issues of the amp are some that I had previously solved and reintroduced when I redid the top boost stuff. I've got some bleed on the normal channel. It's minor, but it's there. And I've got some bleed on the brilliant / top boost channel. It's minor, but it's there. And I want to eliminate that. And I'm going to eliminate that by playing around with the lead dress here. Now here, this red wire is the wire going to this side of the phase inverter, and it's going to these two 220K mix resistors, one from the wiper of the normal channel and one going to the return from the top boost circuit from the wiper of the treble pot. And right here, this green wire feeding the normal channel input it's got a black ground wire in between it and the red wire behind it, but it is passing very close to this part of the signal return from the top boost, which by necessity has to be unshielded right there. And you know, a fraction of an inch can make a difference. And I'll have to be playing around with that with the speaker closer to me so I can really hear it. It's not, the bleed isn't coming through on the camera at all. But it is there when you are in the room with it. Similarly, on the top boost bleed, that might be right here with the feed going from the volume. Oh no, that's gonna be ground. I think that might just be some leakage from the input of the top boost channel through the shared cathode resistor of the top boost and normal channel right here. So this is probably where all the bleed is coming from, this green wire here. And it may be that I just need to get a different wire in here and dress it differently, or shield it, or shield the return wire from this mixed resistor junction. But that's a bit of a pain in the butt. Get a little bit of noise if I move that wire too. I don't like that. There's just not a lot of real estate here. I think I need to replace that wire. Apparently there was some Facebook forum that had a spaz about some comments I made on this amp earlier in this video series about wire becoming microphonic or adding noise. And I think that they thought I was saying that there is a sonic difference between stranded and solid core wire, as if you could hear a difference between, say, 6 inches of solid core versus 6 inches of stranded. And that is not the case. What I was saying is that wire can have microphonic characteristics, and a solid wire that has a certain mass and a certain tension is likely to vibrate at certain frequencies, and a stranded wire, being a little bit floppier, is much less likely to vibrate at those same frequencies. Now in this case, this wire here is stranded because it was very difficult to fit a solid wire in here without pulling this whole board out. I may have to do that and replace this. This wire, if it's responding, making some noise when I do that, this wire could add noise when the chassis vibrates. This is, you know, if this were used in a combo and the whole thing starts to vibrate, what I'm causing here with this chopstick could also happen through chassis vibrations. So that red wire needs to be changed out. I don't have a lot of red wire of the small diameter. I may have to go to the top coat that I usually use, which is more of a Marshall style wire, or just replace that with a bit of a shielded run. That might solve the remaining bleed as well. So I've got some bleed here, and I've got to track down the last of that noise right there. The other issue, and this one is something that might have existed before, but I only discovered it last night. Let me move the camera. All right, if I bring up the level of the normal trim volume, tap on the chassis, there's a noise, and that's not present if I tap on the front panel there with any of the other channels active. So I'm going to see if I can clean those connections on these pots. That may be all that we're hearing. Let me unplug from the amp. All those noises, any of those noises, are bothersome, both to me and certainly to the client who is paying me to make his amp sound better. So I like to get all these things out. So it could be a lot of things. I'm going to start by looking and seeing if it's just needing to be cleaned. Let me power the amp off just in case. And kick the camera. I don't want to spray places I don't want, other than where it's necessary. Now, I did this already on the other jacks. I must have forgotten to do it on this one. So I'm putting the cable in, the plug in, which opens the spring contacts on these cliff jacks so I can get some deoxit right on the contact spots. I'll do both of them. In a previous conversation with the owner, he said he rarely ever used the normal or vibe trim channels. And so if they were just sitting there, this one had a bunch of noise in it, if you recall earlier in the video series. Cleaning that one made that noise go away. This one I think might have just had some corrosion on those jack contacts. So let's power that back on and test that theory. Let's see. All right. So the noise is still there. So let's look at the wire here going from that jack. That's good. All right, but if I touch this solder joint, all right, let me reflow all the connections on these two jacks. I'm going to have to do that with the camera moved and the mic disconnected, so hang on a second. Well, this is one of those things that frustrates me to no end. Reflowing the solder joints on those input jacks over here made no difference. And so I started tapping on things. It's definitely in the vibe trim. That's just a little bit of microphonics out of that top boost tube there. If I tapped in this area, the noise was worse or worst. And then all of a sudden the noise went away. And I've not been able to get it to come back. Which often means there's a questionable solder joint. Not trying to throw the owner under the bus here. So I got to tug on everything. I like to recreate that and then find exactly where it is coming from. All the solder joints look very good in this area, but there was that static noise, which is certainly gone now, but it was before the volume pot, because it's affected by the volume pot on that channel. And the bad news is everything in the vibrato channel from here to here is before that volume pot, including some components back here on this board. In fact, a lot of them. About 2/3 of the circuitry in this AC30, like all JMI era AC30s, is for the trim channel that is often rarely used. Where is that noise? It went away. I hate it when noises go away mysteriously when you tap on things. And it's possible that that noise was a snippet of wire, either from the owner's work or from my own work, that just flew and lodged in a place it should not be, and tapping on things dislodged it. So what I'm going to do, it's very high tech, is I'm going to unplug the amp and I'm going to power it off, obviously, and I'm going to shake it over my bench, trying not to drop it or throw it across the room, and see if any little bits come out. And I'd like to, until I can find and verify what was causing that noise, I don't like to let this amp go back. I'm not too worried about that microphonics you see there. That was a TAD tube that I pulled from another amp, because the Mullard that I had in here decided to die. It's a hostile environment at the best of times. And let's try this other TAD. Mullards, like all tubes, sometimes die. And I already have a replacement coming from the vendor, so it's buying tubes is more a matter of finding a good, trustworthy vendor than anything else. And don't change tubes like you just saw me do in a live amp like this, where he could touch something over here and get killed. I'm either very experienced or very foolhardy, or both. So let's see. All right, this tube has no microphonics to it, so that's good. But why was there noise before? All right, I'm going to shake this thing and see if any little bits of metal fall out, and then I'm going to turn my attention to that red wire that you saw a bit earlier and get rid of that last bit of noise, and then we'll see what this thing sounds like. I'm pretty sure I found and solved it, though I cannot show you the before and after, because in the process of fixing it, of troubleshooting it, part of the process of troubleshooting it was the fix. I'm not going to undo it for the sake of this, but see these, let me see if I can see where I'm pointing, these three together, these are tied, and there's one wire that's wrapped around this one, and it goes and was wrapped around this one, and was just pressed up against this one with solder. Well, I think that solder joint, I mean, it didn't have much solder on it, and that noise was in this area, and I was tapping in here, and it went away. And I think I did, when I tapped right, just right, it made contact between this lug and this wire, and I could have tested that. I could still test it, I'm not going to, by desoldering that and pulling it off. I reflowed that, and I went through the amp and found any similar 3 and 4 lug connections where some just had the solder as glue, and reflowed those as well. And I cannot get the noise to come back. This, you're seeing this 20 seconds after the problem. I went through and spent about 10 minutes in the amp just touching up any similar bridged solder connections. So, the version that you see in these repair videos is not the full repair, because I assume that some of you might have lives unlike me. Okay, this is not JMI, but it was necessary to get the best behavior and sound. This is the new wire going from the two 220K mix resistors on this normal and top boost going to the phase inverter input. So it is a stranded wire, but a tinned stranded wire that has the same behavior as solid. It'll hold this shape, and it is steered away from this wire going to the brilliant channel, top boost channel volume pot, and from this wire going to the normal channel volume pot. And that has removed the bleed from the treble and bass, the normal and top boost channels. And there is no noise now when I tap this, unlike the previous wire. And that should be a very good thing. It's away from everything else. It's running perpendicular to all these components. This wire here is ground, so that's no big deal. So while that is not the JMI lead dress is actually, in fact, better. But this amp has one remaining issue, which is driving me a bit nuts. All right, the Vibe trim channel has got some voltage on the grid of the input triode. Similar voltage is not present on the grids of the normal and top boost channels, but I've got about 28-30 millivolts of voltage present on the input. And what that means is that there is static when you roll your volume pot on your guitar. It's not terrible. It's certainly been higher in a lot of amps, but it's noticeable. And that is caused typically either by a component which is failing or leaking or not functioning properly within the circuit, or the tube itself. Some tubes just emit nasties at their grid when they're not supposed to, and sometimes, rarely, it is lead dress. I first swapped out the tube. The tube that's in there now is a Tube Store Preferred Series 7025, which is a Chinese tube, well sorted, and that's got about 30 millivolts of leakage. I tried a TAD branded 7025, which is also, I believe, a Chinese tube. It had about 200 millivolts, so the problem was worse with that tube. I don't think that tube would necessarily have that leakage if there wasn't some problem within the circuit. And it's possible that it could be the 1 meg grid leak. It's possible that it could be the 68K grid stoppers, but it's much more likely to be the cathode resistor, and then sometimes, but much less likely, the cathode bypass cap. With a brand new Sprague Atom, I doubt that. Now, I wish I had noticed on this amp whether it did have this problem before. When the amp came in, it had a 2.2 cathode resistor here, which is the stock JMI value. And I changed that to an 820 for a bit more gain. And I don't know whether that problem was there before, but it's certainly there now. And I have reflowed that solder, and it is still there. So I'm going to change out this 820 for a different one and see if that's the case. It's not like a 2.2K would not have leakage and an 820 would. The bias that I changed it to is very much within the Fender Marshall Vox standard range of things. It's nothing unusual. Should not be causing grid leakage, but it's possible that I just have a bad resistor. So let's find out. All right, I have found the enemy, and it was me. I was the source of that leakage. I was trying to get more gain out of this channel because it is notoriously a wimpy channel, and I went a little too far. And I would have got away with it if preamp tubes were perfect things, which they are very much not. V7A's cathode in stock form is a 2.2K resistor. It's that one here, and I changed to an 820 ohm, and that gave a modest gain increase. And then V7B's cathode is another 2.2K resistor, but that one's bootstrapped through a 22K resistor to ground, and that's that 22K back there. And I put another 22K in parallel with that, which gave the whole stage much more gain. And I really like the sound of it, but it was introducing that DC on the grid, and it's because of the way cathodes and heaters work. I'm not going to get too far into it, but I just had a poor relationship between the cathode voltage and the heater voltage, and nastiness was leaping to the grid. Let's just say that, because the real explanation is 30 minutes long. This video is already much longer than I expected it to be. So, all the yuck when I turn the volume knob is gone. Now that's going to sound terrible on the video because the amp is 15 feet away in the other room with a heavy curtain between us and it. I can hear this stuff, but I'm sure it's picking up on the mic like crap. You will soon hear what I hope to be the final playing video of this amp with the real mic and all that set up. I was going to do it all in one video, but this one has already gone long enough. So I will check back after I get set up to do the real video. But it's so much nicer now with that noise gone and all the mystery stuff happening when you tap the chassis. If you hear a noise, it's not the amp about to blow up. It's my neighbor starting a leaf blower because my life.